You remember in the last session we discussed about how null hypothesis is required and also how it works to test the significance of the obtained sample statistics. We also talked about the levels of significance and also about how these levels help in deciding the rejection or retention of the null hypothesis. We also discussed how to conclude on the basis of the statistical analysis. We started talking in the last session about Z scores, how they may be obtained by using the normal distribution values table. Do you remember my two postgraduate students who were very much keen to know that what these Z scores are, how they are figured and also how to use them for taking decisions statistically in different situations to reach a conclusion. After completing the session with you, I gave them some very short assignments and asked to complete the same collectively by consulting available related literature in the library and on the internet. That day when one of their teacher was on leave, I interacted with them. I tell you, I was really surprised to see their presentations. How that session went on, I shall now work with you in the same way. Let us go back to the assignment of the last session when we decided to complete before the start of this session. Have you calculated the mean and standard deviation of that data? Oh, very good. I am happy that all of you have completed your assignment. I tell you very personally that it is a routine feature of my teaching style. In the end of every session, I shall give you also an assignment and you shall have to be very much regular with me. Okay. Let us start with the value of mean and SD you have computed. I know that the total number of the data was 30 and the value of mean is there on the board along with the value of the standard deviation. You know that the standard deviation is the root point of every parametric statistics. Before we move further, let us have a geometrical conceptualization of it. Suppose I have a data of 5 subjects A, B, C, D and E, which is arranged in an ascending order. The variation among all scores is that of 1 score. Look at the screen. The mean of the data falls at C score. Now, I wish to find out the standard deviation of this data. For this, if I observe the deviation of all scores from the mean, the obtained 5 deviations shall be like this. See as I have drawn on the board. To get the standard deviation, I may have to calculate the mean of these deviations. To add them mathematically only possible after converting the single dimension deviations into squares, like this as I have done on the board. Now, we add these squares to get the sum of squares. Now, to calculate its mean, I have divided it by the total number of scores, which is 5 in our case. Look at the average of the total sum of the squares of the deviations between scores and the mean score of the group. This depicts the average of the area which exists between the mean and the scores of the data and the total variance in the group. To get the average of the deviation, we have to convert back the obtained average of the sum of squares of the deviations into single dimensional figure by computing its under root. You can see a line which I have denoted y to z. This line represents the standardized average deviation among the mean and all scores of a group, and this therefore is the standard deviation of the data. This way you may realize in what way the standard deviation represents the variability of the data and how it is obtained. You may see on the screen that the standard deviation has been evolved by using the mathematical operations in the form of under root of the average of the sum of squares of deviations of scores from the value of mean. Now look how the same mechanism is applied to get the z scores. You know that z scores are nothing but the standardized scores, which represent the value of the score of the sample data on the continuum of the distribution of data of the entire population. Commonly we call it as normal probability curve, that is NPC. Before I discuss further on z scores, we shall do another exercise on the values of mean and standard deviation you have computed. Suppose you want to know the position of a score, say the score of 7 on the entire continuum of the population. For this, we may have known its deviation from the sample mean, and that is, as may be seen on the screen, is from m to x. Now we need to compare this deviation from the standard deviation of the sample to make it also standardized. Therefore, we find out its ratio by dividing it by the value of standard deviation. On the screen you may see how the deviation between m and x is compared with the standard deviation, that is depicted as y to z. In our case, we find that the value of m to x, that is lesser than the value of standard deviation. Therefore, the value of the standard score for x shall be less than 1. In our case, it explains the position of the score x on the continuum of the population distribution. Look on the board. To make it more clear, we suppose if the deviation of the score is of the same magnitude as that of the standard deviation, the value of the z score would be 1. See how it happens. Look at the normal distribution, which is presented in the form of normal probability curve. All the scores whose deviation from the mean is equal to the magnitude of the standard deviation of the sample, they all are placed on the z score of value 1 on either side of the mean, depends upon their value. Thus, the scores deviating from their mean equally to the value of standard deviation of the sample are represented by 1 z score. If these scores are greater than the mean value, they are placed on the positive side of the normal probability curve, and have the value of +1 z score. And if they are on the negative side of the normal probability curve, the value of z score is -1. To make it more explicit, take the score which is equal to the mean value. The deviation of the score from the mean shall be 0. When we divide this value by the value of standard deviation, the standard score becomes 0, meaning thereby the score whose value is equal to the value of the mean has no deviation, truly representing the group and is merged into the true value of the population. Therefore, it is 0. This exercise has helped us to conceptualize the emergence of z scores and also to get an insight how we may use z scores in taking our statistical decisions. Before we proceed further, let us revise the computation tool of obtaining the z scores. This is equal to the difference between the targeted score x and the mean of the group M divided by the standard deviation of the sample. Now, if we have to take a decision that to what extent we may depend upon the value of mean while using it for the entire population, for this we have to test its dependability by establishing its reliability statistically. Why we have doubt on the reliability of sample statistics? We have talked about it in our previous session as well. You remember, in behavioral sciences, when we take observations on a sample, there are chances to get deviations on account of several reasons. These may be related to the sample as well as to the way the observations are collected. While dealing with the human behavior, there are always chances not to get the normal observations, and hence the findings on the data remain under question. For testing the significance of sample statistics, we need to know the extent of the deviation which has occurred. In other simpler way, we may say that to estimate how much error exists in the obtained value of the sample statistics. Here, the concept of standard error evolves. Standard error of any statistics may be the standardized deviation of the sample statistics from the population parameter. In case of mean, the standard error may be computed by dividing the value of the standard deviation of the population by the square root of the size of the sample. Actually, the standard error of the mean is nothing but the square root of the variance of the single score. How it is computed? This question you might be having in your mind. Simply, it may be computed by dividing the variance of the population by the total number of observations and then taking by its under root. Another way to make it more easy, you may divide the standard deviation of the population by the square root of the size of the sample. Look on the screen how these two formula are the same. This way we may compute the standard error of mean. I am sure that you must have noted here that I used the term standard deviation of the population very specifically, whereas you might have a question for me that the standard deviation you had calculated was that of the sample and how I could use it as the standard deviation of the population for arriving at the value of standard error of mean. I very much agree with you. It is a reality that we can never calculate the standard deviation of the population. We can only estimate it on the basis of the values obtained on the sample data. Here, in case of standard deviation, we assume that if the size of the sample is large, the value of the standard deviation obtained may be considered as that of the standard deviation of entire population. You may further ask me that what about the data where the number of observations are less? Oh yes, you are right. To have this query in behavioral sciences, especially while working by manipulating situations, we generally take a small group for so many reasons. In such situations, a researcher needs to know how to estimate the standard deviation of the population on the basis of the scores obtained on a small sample. Here, the concept of degree of freedom enters, which I shall discuss with you in another session. Now, let me be brief in this regard to pay my attention on the dependability of the statistics, this time specifically that of mean. Before I discuss further on the issue, I tell you that in case of small samples, we subtract the value of 1 from the value of the size of the sample while computing the value of standard deviation. This way, for small samples, the average of the sum of squares of deviations of scores from the mean of the sample is computed by dividing it by the degree of freedom, that is, in this situation shall be obtained by subtracting 1 from the size of the sample. In simpler form, n minus 1. You may see on the board the formula of computing standard deviation for the large and the small sample to estimate the standard deviation of the population. Now, we shall focus on establishing the reliability of sample mean m, which you computed. In our case, we have to decide statistically to what extent we may depend upon the value of mean we obtain. We have learned how we may compute the standard error of mean. Let us compute it. You also compute in your notebook. As the size of the sample is 30, we may consider the standard deviation of the sample as the standard deviation of the population. Now, at this point, after computing the standard error of mean, we have to decide that how much precision we may need to have in our statement regarding the reliability of mean. It may be at 0.05 level or maybe up to 0.01 level of significance, depends on the need of the researcher. We have discussed, you remember, these levels of significance in our last session. We know that The value of Z scores at 0.05 level of significance is plus minus 1.96 and at 0.01 level of significance it is plus minus 2.58. Let us decide that we shall limit our statement up to 0.05 level of significance. That may be true for 95% cases of the population or shall be obtained in 95% cases if the same procedure is repeated. In this case, we shall first multiply the obtained standard error of the mean with the Z score or the critical value which is at 0.05 level of significance, that is 1.96. Then we shall use the obtained value in estimating the lower and the upper limit of the mean, which may represent the population parameter. This shall be done by subtracting and adding this value in the obtained value of sample mean. On the basis of the acquired lower and the upper limit of the mean, we may give our conclusion on the reliability of this mean by stating that the mean of the population shall not be lower than the minimum limit and not be more than the upper value of this range. The population mean shall lie somewhere between these two values for the 95% of the population, and if the same procedure is repeated 95 times in 100 observations. During this exercise, we had been able to establish the reliability of mean only. There are other very significant statistics as well, like standard deviation, coefficient of correlation, etc., which we use very often in taking decisions about the groups we are dealing during our course of teaching or research. Here I may assure you that once we get into the process of establishing reliability of mean, it also empowers us to use the same way for establishing reliability of other statistics as well. The only difference we have to do is to use different way in computing the standard error of that statistics. Rest remains the same. I hope during this session we have acquired an insight into the basics of the inferential statistics. This insight shall play an important role in understanding the further course of inferential statistics. Complete the assignment by learning the ways of establishing reliabilities of all important statistics and enjoy the meaningful world of estimation and inferences. We may meet again. Okay, bye.